to deliberately infect an entire alien ocean with life from Earth. What is considered the ultimate cosmic crime for decades is now being seriously proposed as the greatest scientific experiment. And the target for this audacious plan is not Mars, but a small, shimmering moon of Saturn named Enceladus. At first glance, it is an unlikely candidate for life, a tiny ball of ice just over 500 kilometers in diameter. But data from the Cassini spacecraft, which studied the Saturnian system for 13 years, transformed our understanding of this world. Cassini revealed that Enceladus is not just a dead ball of ice. It trembles slightly as it orbits Saturn, a telltale wobble that suggests its solid icy crust is decoupled from its rocky core. The only thing that could allow for such a phenomenon is a vast, global ocean of liquid water hidden beneath the ice.
The most stunning discovery was the geysers. From deep fissures near the moon's south pole, dubbed tiger stripes, massive plumes of water vapor and ice particles erupt hundreds of kilometers into space, feeding Saturn's faint E-ring. Cassini bravely flew through these plumes on several occasions, tasting their contents. The findings were astonishing. The water was salty, and it contained a rich cocktail of organic molecules. It had carbon, hydrogen, nitrogen, oxygen, and even phosphorus, a critical building block for DNA that was the final piece of the puzzle. The plumes also contained molecular hydrogen, a potential food source for microbes, and a chemical energy gradient that could power life. In essence, Enceladus appeared to have all the necessary ingredients for life as we know it: liquid water, essential chemical elements, and a source of energy. This presents humanity with an incredible opportunity, but also a monumental engineering challenge. How do we get to this hidden ocean, buried beneath an ice shell estimated to be tens of kilometers thick? The most discussed idea involves a cryobot, a probe that would melt its way down through the ice, slowly descending into the dark alien sea. It would be a journey of immense difficulty and patience, culminating in the ultimate question: is there anything alive down there? The fear that haunts this grand ambition is the possibility of finding nothing. After decades of planning, a long journey through space, and a perilous descent, we might discover a vast, sterile ocean. This is where the radical new idea, published in the journal Space Policy, comes into play. The researchers argue that a lifeless Enceladus should not be seen as a failure, but as an opportunity. It could be the perfect blank canvas for the greatest biological experiment ever conceived. If the ocean is indeed sterile, they propose using a probe similar to the cryobots designed for exploration to instead introduce terrestrial life. This act of deliberate inoculation would serve two profound scientific goals. First, it would be a direct test of whether life can take root in an alien environment, helping us understand if Earth is a unique cradle of life, or if life is a more common cosmic phenomenon. Second, it would give us a front-row seat to watch evolution in action in a completely new world. We could observe, over centuries or even millennia, how simple microbes adopt, spread, and potentially change a world, giving us a glimpse into how life may have started on our own planet. The candidate chosen for this interplanetary journey is a specific type of microbe, an archaeon called Methanobacterium subterraneum. This is not just any bacterium. It is an extremophile, discovered deep within Earth's crust, thriving in groundwater flowing through granite deposits hundreds of meters underground, completely cut off from sunlight. It survives by consuming hydrogen and carbon dioxide and producing methane as waste, a process called methanogenesis. This is significant because the chemistry of Enceladus's ocean seems perfectly suited for this process. The presence of methane could serve as a detectable biosignature, a sign that our introduced colonists were thriving. This organism is incredibly tough. It's non-modal, can survive in a wide range of temperatures and alkaline conditions, similar to those predicted for Enceladus's ocean, and could potentially show signs of successful colonization relatively quickly. However, this proposal leads us into a profound ethical minefield. The single most important condition for such an experiment is the absolute certainty that Enceladus is sterile to begin with. This is an almost impossible bar to clear. Proving the presence of life is difficult enough, but proving its complete absence is a far greater challenge. If our probes search the ocean and find nothing, it does not mean there is nothing to find. It only means we have not found it yet. A negative result is not a confirmation of sterility. The risks of getting this wrong are immense. If we introduce Earth microbes into an ocean that already harbors a native, albeit subtle, biosphere, we could become cosmic invaders. Our robust terrestrial organisms could outcompete and potentially eradicate an alien ecosystem before we ever knew it existed. This would be an unforgivable act of biological destruction. From a purely scientific perspective, the damage would be just as catastrophic. We would contaminate the experiment permanently. Any life we might discover on Enceladus in the future would be suspect. It would be nearly impossible to distinguish between native life and the descendants of the organisms we introduced. We would have forever clouded the answer to one of the most fundamental questions we can ask. Are we alone in the universe? The very act of trying to create a second Genesis could prevent us from ever discovering a first. The debate forces us to weigh the incredible potential reward of observing life take hold on another world against the irreversible risk of destroying it.